TOEFL Strategies, Track 9.
Listen to part of a lecture from an earth science class.
So, today we'll begin to discuss the chapter you've read on plate tectonics. When we look at a map of the world, there are 7 continents, right? Can anyone tell us what they are? Yes. Greg?
That's easy. The 7 continents are Europe, Asia, North America, South America, Africa, Australia, and Antarctica.
Good. And some of the continents are separated by oceans, right? America and Europe are separated by the Atlantic Ocean. Africa and Australia are separated by the Indian Ocean, and so forth. But if you look closely at the coastlines of some continents, it almost looks like they used to fit together like a puzzle. This is particularly noticeable along the eastern coastline of South America when you compare it with the western coastline of Africa, for example. While it may seem an obvious point when we look at the world map, this idea wasn't scientifically presented until the early 1900s when a meteorologist named Alfred Lothar Wegener proposed the theory of continental drift, stating that the Earth's continents were once one big landmass. The theory suggested for the first time that the continents came to their present positions only after moving for millions of years. This one original landmass is known as Pangaea. Can anyone tell me more about Pangaea?
Pangaea means all lands in Greek, which is why the word was chosen to describe the landmass. And didn't another scientist divide Pangaea into regions?
Yes, that's right. It was divided into an area called Laurasia in the north and Gondwanaland in the south. Very good. Now on to the theory of plate tectonics, which was presented scientifically only about 30 years ago. In geology, a plate is a large slab of solid rock, and the word tectonics also comes from Greek, from a word meaning to build. So, the theory of plate tectonics explains that the Earth's surface is built of rock plates. This means that the outer layer of the Earth, beneath all of the continents and all of the oceans, is fragmented into large and small plates that are moving in various directions relative to one another's positions. Can anyone tell us about the place where 2 plates meet?
Yes. Between 2 plates, there's a boundary called a fault line. There are different kinds of boundaries.
Right. Do you know what they're called?
Let's see. There's divergent boundaries, where the plates are pulling away from each other, kicking up new crust. And then there's convergent boundaries, where one plate slides underneath another plate.
I think there's another one, the transform boundaries.
Good. Yes, you've got them all now. Divergent boundaries are where the plates are pulling away from each other, and convergent boundaries occur where one plate slides underneath another plate. This one's sometimes called a very slow collision because some of the Earth's crust is destroyed in the process. Greg, can you tell us about transform boundaries?
Yeah, sure. The transform boundaries occur where 2 plates slide past one another without creating or destroying any crust.
Oh, and then there's places where the boundaries between plates aren't clearly defined, and we don't know how those plates interact. I think those are called plate boundary zones.
Very good, both of you. So we have the 4 types of boundaries between plates: divergent, convergent, transform, and plate boundary zones, and all of this occurs far beneath the surface of the Earth. Now, let's talk about some features of plate tectonics that we can see on the surface landscape. What are some natural features of the Earth that are formed by plates moving at their boundaries? Yes?
So there's mountains, volcanoes, and I think earthquakes too, right?
Yes, that's right. So let's discuss all three of these. Mountains first. Plate tectonics formed some of the most impressive mountain ranges on Earth. The Himalayas were formed at a convergent boundary when the Eurasian plate crumpled up and slid over part of the Indian plate, bringing India and Asia together around 50 million years ago. After the collision, the slow, continuous convergence of the two plates over millions of years pushed the Himalayas up even higher to their present heights. Now, for volcanoes, we have to go back to plates for a minute. Plates are actually part of the Earth's mantle, and below the mantle is another layer called the asthenosphere, made up of hot, partially molten, that is liquefied rock. You can think of a volcano as a vent, which when opened allows the hot molten rock from the asthenosphere layer to leak out.
Now get ready to answer the questions.